Oh, completed. Huh? Okay, now we'll take the general discussion. We'll make it some 20 minutes is there. And now, if there is a and we have a rod here. Okay, I think let's take a point mass. There's a sphere of, there's a shell, huh? And there's a point mass, which is at a distance, say like a r, or say let it be x. Now I want at point P, at a distance r from the center of shell, what is the gravitational field strength? What you are going to do here now? Superposition principle, the net field at point P. Net field at point P, what all we do? First due to shell, then due to the point mass. I think that's the only alternative available, no? No need of anything. The net field at point P is field due to shell, field at point P due to point mass. Okay, now, what is the field due to shell? We know inside the shell, what is the field? Should be zero. Due to point mass, how much? Gm1, what is the distance? It will be x minus r whole square. How it will be directed? Towards right. Okay, got the idea? When they ask you about the interaction, so you can use this basic method here. In electrostatics, things are different here. Here, just the field at this will be due to the point mass and also due to the shell. Like this, due to two concentric shells, we have done. But so like a there it was zero inside the shell because the mass is distributed symmetrically with respect to center of Gaussian surface. Here, like if you draw a Gaussian surface here, some students they're asking, sir, I'll draw Gaussian surface. What about this mass? See, what is a Gaussian surface? It's an imaginary thing which you are drawing. It's a mathematical idea you're bringing it. It's not physically exist. Gaussian surface will not physically exist. What is the meaning of this? So I'll put it in a simple way. There's a Gaussian surface. A point mass is here. Now you tell me, what is the field strength at point P? So net mass enclosed by Gaussian surface 0. Net mass enclosed by Gaussian surface should be 0. So therefore field strength at point P should be 0. No, it will be non-zero. But integral of E bar dot ds will be 0. Because net mass enclosed is 0, but EP will be non-zero. Just a logical thinking, nothing else there, no concept, nothing. What is the net mass enclosed? 0. So in the RHS, what will happen? 4 pi g into net mass enclosed 0. So therefore integral of E bar dot ds will be 0. But what is the field strength due to this particular point mass? Will be there. So what is the Gaussian surface? It's an imaginary diagram which you are bringing to solve the problem. There's nothing called like a physically any Gaussian surface existing. Are you getting the idea? If physically any Gaussian surface exists, then things would have been different here. So what is this? This is a imaginary diagram. There's a meaning of this. That's why I just picked up this problem. Okay, we'll take the next one. Now due to hemisphere. So first we'll take the due to hemisphere, solid hemisphere. One problem will do that. I think time will make it out. All of you getting the solid hemisphere. We have to calculate the field strength at point 2. So what is the radius of this? R, mass is m. Solid hemisphere. You take lemon, cut into two parts, two equal parts. That each part, what pen will become solid hemisphere. Okay, it's not a ring. Lemon, watermelon, cut into two equal parts. And what is the field strength at point 2? I am testing your pure mathematics, nothing to do with one. Already we know physics. We know like a gravitational field due to point mark. That is enough. That physics is over. It's all about now how good you are going to use mathematics here. So where is that point 2? At the center of the base. At point 2, you have to calculate. Find E bar at the center O of the base of solid hemisphere. Okay, no, get into the problem. What we have to do here? Elemental structure. What elemental structure? Disk. Do you know gravitational field due to disk? Yes, you know it. Now carry on. So what ideas we know? No, that has to be applied back here. So let me take some better diagram. Okay, you meanwhile draw rough diagrams in your notebook. I'll adjust the one diagram. Let it be here. Okay, this is a hemisphere. What is the elemental structure? The disk, what we have to assume it. I'll start with this. Okay, it's a disk only. I have to show it in this way only. It's in fact it's a disk. So now there's a disk, thin disk. Mass of this disk, let it be dm. Then there's a point to at which we are supposed to find out here. Okay, let's get into the mathematics now. This at the corner, no, I'm showing that part is very important. I think in the so let this be ds. Let this be x. This one, ds and dx will be different. Already, I think in or dy, it is in center of mass. You might have come across. Let it be this one, and let it be at a distance y. and let r be the radius of this. First, we should define that dm. Until the dm is not clear, we can't do one thing. And it's a thin disk. What is the mass of the disk? Dm. Then if you know once the mass of the disk, no, then the field strength at point 2 due to that thin disk will get it. Then we'll integrate, we'll get the required answer. How to calculate dm? And what is the sphere, no? So what is the density of this? Let rho be the density. Let rho be the density here, no? So now first I'll get into the dm part. Dm is equal to rho into what is the thickness, what is the area of the disk? Pi r square into dy. If you look at that small triangle, so this is what we define theta. This is dy. This angle will be theta. Here, you have to look at this one. How this ds and dy are related is what? I'm writing the equation. Then this will become equal to dy, so sine theta so this will be rho pi r square, dy will be ds into sine theta. What is d and what is sine theta from another triangle? Sine theta equal to small r by capital R. And ds equal to what we can write? Ds equal to r d theta. This is angle d theta. So let me substitute all these things. Rho pi r square. This small r, what we can write it as? R sine theta whole square. ds what you can write? R d theta. And let this be sine theta. So rho pi r cube sine cube theta d theta. This is what? Mass dm. Now I know the mass of elemental disk. Now we'll calculate the field strength at point 2 due to this elemental disk. Okay, go back to the formula. What is the formula due to thin disk? Sigma by anybody? Formula due to thin disk? Anybody? Thin disk we have derived, no? Yesterday's. It was in terms of sigma, no problem, no problem. We give in terms of sigma only. Now, what is rho you can write? First, I think we should define rho, no? So rho is what? M by 2 by 3 pi r cube. If I substitute that also, please give that value of this one, field due to the thin distance one. So pi r cube get cancelled. So this will be 3m by 2 sine cube theta d theta. This is the mass of that elemental disk. Rest all everything is what will enter into the now due to this the field strength at point 2 due to this disk should be sigma by anybody value. Okay, I'll check my notes. That one yesterday's notes. No, it is
when 2 pi sigma g into
2 pi. Yeah, 2 pi sigma g into 1 minus. Will I agree this? The
yes.
formula. Okay, now I'll do one thing. I'll just bring this small disk here. Agreed, no? This is what that DE. Let's assume that one. But we have here row. What we have? We have M here, no? Can you bring in terms of M? So what is M? Sigma, what you can write? M by pi r square. Can I change things like that? But sir, rho is there, then now you're making sigma. Sigma is what? Area density. So for this particular thing, what you should write? Sigma by, so how to make it? So sigma is what? You're going to write it as, if the total distance, no, M by pi r square, it would have been like this. I'll come to the question later on. Okay, this is like this. It is okay. In terms of mass, can you bring the equation like this? There's a background. If you can get set at rest all integration and we'll get the answer. It's over. Almost we are at 80% of problem got over. We'll agree this because what we have M or rho, or in terms of M we should bring. But what we have formula is sigma. So what is a, for a disk, what you can write sigma? M by pi r square. So this pi get cancelled. So this will become 2mg by r square. Pi get cancels. 1 minus x by root of, there's a background. We are going to use this data. Okay, let's come for this. Do we know mass of the thin disk? Yes, we know. We know radius of the thin disk, small r. So in place of capital R, what shall I write? Small r. In place of m, dm. In place of x, y. I agree this one. There's no other way. You have forcibly you have to put some pressure on your mind to accept this one. Nothing is there. So therefore now d e naught, this should be equal to 2 dmg. What is the radius of that? R square 1 minus y by root of r square plus y square. What is dm now? The dm is this much. That will substitute here. So now this will be 3m by 2 sine cube theta d theta 2 g by r square 1 minus y by root of r square plus y square. Okay, agree this, sir. So many terms. How to integrate? What to integrate here? So this y by root of r square plus y square, what you can write it as? Cos theta. 2 get cancelled. So this will be 3m g r square sine theta d theta 1 minus, account to the thing. What is cos theta? You can write it as y by root of y square plus r square. I'll draw one small triangle so that you'll be in better position. No, can we integrate this? One r square is left over. No, what to do with r square? R square is left over. What to do with r square? I would have just gone to the integration straightforward. Shall I bring smaller here? Smaller, what you can, capital R sine theta. Agree this? Capital R sine theta. Sine theta equals smaller by capital. So here what is the equation from this? What we can write? Means now, okay, this is something cos theta. So small r will be r sine theta. Sine cube. R square will come here. What is the next thing? Sine theta d theta 1 minus cos theta. What should be the limit, anybody? 0 to pi by 2. 3 gm by r square. No, get into the thing. This is what? Some lot of calculations are there. I'll push it here. Yeah. Okay, no. So for finally, later on, if you want, I'll bring back the row later on. Huh? Okay, this will become 3 gm by r square. Integral of sine theta will be cos theta 0 to pi by 2. So this will be 1 by 2. I'll adjust. This will become sine 2 theta d theta 0 to pi by 2. So this will be 1 minus 1 by 2 cos 2 theta minus of minus, this will be plus. I think we have to be, okay, no. Anybody value of this? Cos 2 theta cos pi minus 1.
Sir,
Integral of sine theta is minus cos theta. Yeah, with this. So this will be sine 2 pi. So sine cos pi will be minus 1. Anybody value this limit? Okay, I'll do one thing. I'll solve it. Cos of cos pi minus of cos 0 minus 2. We are getting total 0. Where I change it. Calculation, everything correct. Cos theta replacement, okay. Then sine theta. Small r is what? Sine theta d theta. Minus sign, so negative of negative.
Sir, In the last step, it is EGM by r square 1 plus 1 by 4 cos 2 theta, sir.
1 by 4. This one, huh?
Yes, sir.
1
The
by 4.
last step, sir. Yes, sir.
Why 1 by 4?
Sir, integral of sin 2 theta is cos 2 minus cos 2 theta by 2, sir.
Okay, that 2 adjusted. Huh? Okay, 1 by 4 will come here. Huh?
Yes, sir.
Here this will be. Huh? Okay, fine. Next again. Next step, this limit, okay, limit cos pi. Minus of cos pi is -1, -1, -2 it will come. So minus 1 by 2. Okay, this one. Yeah. 3 gm by r square 1 minus 1 by 2. 3 gm by 2 r square. Okay, this r square will be there. Huh? Yeah, fine. Okay, this is a gravitational field strength due to that solid sphere. If you want to bring in terms of the density, no, so what you can write m as rho into 2 by 3 pi r cube. Mass you can add rho into 2 by 3 pi r cube. Substitute that in terms of density it will come. I think some books they're given in terms of density. Okay, substituting this 3 by 2 r square g rho 2 by 3 pi r cube. G rho r. I think that is not the answer.
Pi g rho r, sir.
Pi g rho r. This is not the answer. I'll check. I think some books has given anybody. 2 gm by 3 r square. 3 gm by 2 r square. Okay, this is the answer. Yeah, fine. Okay, this is our answer. Huh? Solid sphere. Yeah. In terms of rho, you can simplify it. Pi g rho r. Okay, just look at the mathematics, huh? the way I did. Some books they're given in terms of rho. Here I brought in terms of m and rho, both the things. Huh? This will be our answer. I don't think so in exam anybody will ask. Please do remember this formula. It's going to help us a lot. That's all. So like this, what happened? The elemental structures you're supposed to have a lot of maths involved in exams. Nobody will ask you to derive, but the end answer is going to help you a lot. Like this for hollow hemispherical shell you work out. There what happened instead of disk, you should assume a ring and you have to carry on the problem.